Hello guys, we will be talking about the application for logarithmic and exponential equations. Right at the top you can see here. Now I'm going to be explaining our favorite topic of logarithmic and exponential equations because I think that that is a key topic to learn and might be in the SAT, and I think it is very essential that you know this topic, and it's very important for your interest, compound interest. I'll be giving you 3 4 formulas that you should know that will be crucial for anything that has to do with compounding, and with this can be used in scientific ways and it can be used in your mathematic equation like ways. So mathematics, for example, banking, your compound interest, when it keeps adding up your interest when banking, that's when you might need this formula. You might also need it when you're talking about half-life of radioactive decay going on in science, and there are obviously more topics to it, but I will not be going into that. I'll be doing word problems with stocks. uh, we're going to be talking about the value of certain objects and how they decrease and increase over time. Specifically, if, for example, you have like an iPad or a certain device, we obviously don't know exactly the amount of the rate specifically that it will lose its value over time, but we do know that electronics do lose value over time, so that's another topic. And this is more word problem related, but you need to know these specific formulas because they'll help you out a lot. So let's get started. Interest. A equals P 1 plus R over N and T. You can see that all going on here. Compound interest, important for your banking. Now, as you can see right below, you know exactly what all these variables are. A, your end amount. This is what you're trying to find out of using the compound interest formula. P, principal initial amount. So that's your initial amount you start out with, and I'll give you specifically what kind of context it needs to be in your initial amount. So then you have R, that's your rate, specifically R here, that's your rate that you need to know. N, that's your number of times per year. So that's how many times you're going to be compounding the interest per year. Rate, decimal form, that's very important. It has to be in your decimal form. They'll always give you most likely in percentage. So you need to convert that over to decimal form. Then T, your time period, number of years. That is the number of years you're going to be compounding over time. So now we have our different ends, which is basically the number of times per year that it's compounded. So not always it's going to be your daily, yearly compounding. You might have monthly. If the word problem gives you monthly, 12. If it gives you quarterly, 4. Semi-annually, 2. If it gives you, what do we have here? Weekly, 52. Daily, 365. Now, it's pretty simple to find out how you can actually find out this thing. Daily, 365, obviously 365 days. Now, specifically weekly, I feel like we're not very common with, so there's actually a way to find out weekly. Very simple. You have 365 divided by 7, and that's how you get the weekly amount of 52. Now, it might be need to round, but I'll just show you right here. So this is my high quality calculator, my TI 84 plus CE. Obviously, I'm okay with promotion. If Texas Instrument ever wants to get a promotion from me, I'm happy with that. This is an amazing calculator. You should get this yourself. So, boom, right here are your numbers. We're going to put in our 365 days. You just forgot how weekly is, but you know obviously because it's a common number, 365 is the amount of days per year. Knowing that, I'm blurry here. Knowing that, then you're like, okay, yeah, 7 days 7 days a week. Divide 7. Boom, comes up here. What's the answer? 52.14, blah, blah, blah. Exact same. 52, 52. You round it to the whole, you got 52 days, because you obviously can't have 52.1 kind of days or weeks. So that's actually your correct answer right there. That's the way to find weekly, and then obviously pretty much you use the same formula for everything else. Monthly 12 is pretty common. You could go using January, February kind of stuff and get 12 months. I mean, you don't really need to actually do any math for that. Weekly, I think, can be a little bit more confusing. You could obviously count the weeks, but that can get hectic. So yeah, that's your compound interest. So now we're gonna go on to the next thing: continuously compound interest. Compounded interest. Now this is where you use E. Very important to know. E. E is your number that is going to be used for continuously compounding, because it's pretty much your compound interest formula that we were looking at before, but this is your like crucial number that can tell you really the stuff. And you could think PERT as a thing, PERT, as you can see. Now we have the end amount, same, initial amount, your principal. E is just your E number. E to the first would be, E is actually its own irrational number. So over here on the calculator, E comes to the X here. You just go second, and you go E right here. It's kind of hard to see. E right here. Click that. I'm trying to show you E. You want it to the first power to show you exactly the value here. That's your number, 2.718. And now I would go into more details of E, but we're not going to do it. We have to actually go to the word problem, so let's actually go to that. But nice calculator. Use A PERT, so P initial amount, rate, decimal form, remember, they'll give you it in a percentage, change it to decimal, time period, number of years specifically for the time period thing. T, remember time, R, remember rate, P is principal, also known as initial amount, A, your end amount. Okay, now there are two more formulas that we're going to look at. Basic exponential growth model over in this corner, basic exponential decay model. These formulas you specifically use for, so the continuously compounding you use for your half-life. One of the formulas, there's obviously another one you might learn in science as well. So remember that this is just one way, more mathematical minded with E. Use compound interest, a normal standard formula for banking. And actually you can use pretty much the compound interest formula in the same way as you use the basic exponential growth model, basic exponential decay model. This is pretty much the same thing, but we take out the whole n value in it because it's 1. So what's the need for that? It's just compounded like 1 per year. So basic exponential growth and exponential decay. You use this for your like basic growth in numbers. The decay you can use for the devaluation of a certain object, and growth could be maybe the value increases and other problems like that. So what we have here is your basic exponential growth, y equals a 1 plus rt, y is your ending amount, r is your rate, your decimal term. It needs to be in decimal. Then a initial amount, and t is your time period. So for all of them, initial would be pretty much your a in this case, even though it should be maybe a p if you want to think about it like that. Y end amount, 1 has to be there because 1 plus shows the increase, 1 minus shows the exponential decay. And then you've got plus r, which is the rate of increase, and then t, the number of the time period, like per year, specifically per year. Then when you answer word problems, don't forget to include units. It's key to write your answers with units when you're answering word problems. You have to remember that, especially in these kind of problems. They need to know what your number stands for. If you're trying to look for time periods, remember to put years. If you're trying to look for end amount, you need to put the dollar sign or whatever sign it's supposed to be. It's supposed to be percentage, put it in percentage form for maybe the interest. So that's pretty much what you need. You need to include those units in there. Okay, now we're going to go and do some practice. Leah deposits $500 into the account that earns 5% interest, 5% annual interest compounded quarterly. How long will it take her to invest her investment to reach 600? So for this one, annual interest compounded quarterly, we're gonna use our long one. We're gonna use the a equals p principal 1 plus rate over n the n compounded how many times? Time. Compounded quarterly we know is 4, so we can just erase that, put in a 4 over here. Then 5% annual interest, that's your 5% annual interest, so that's what you need to put. Now 5% decimal form, has to be in decimal form, so put 0.05, move the decimal over 2 spaces. Principal, how much did we start? What was the initial amount? The initial amount she deposited was the 500. Erase that there, so you can put the formula down and then erase it, erase the variables and put in the key numbers. 1 stays plus that. Oh yeah, right, the n that came here needs to be included here as well. How much to reach 600? That is the end amount. That is how much Leah wants to end with. So what are we trying to look for? We're trying to look for this t over here. That's the important thing to look at. End amount 600, 500 initial, 1, that always is included, plus your rate, decimal form 0.05 given here. 4 is, we know from compounded quarterly. Quarterly 4. So that's what you put there. Then 4, and then obviously you put that again, t. So now what we do is, now to know how to do this, especially to find the exponent of things, you need to know logs. That's in an earlier lesson of mine if you want to know. So actually watch that one before if this is a confusing step for you. So first of all, we want to put the logs thing together, and we want to put the other side together. So what we do to find out t is we first divide that 500 value over this 500 value over to 600. So what happens is you have 600 over 500 because we moved this over equals 1 plus 0.05 over 4 t. Now this is what it is. Now obviously we need to simplify this area here, so now we're going to put this in our great calculator, and if you were to put it in, you could put like 1 parentheses 0.04 or 0.05 over 4, or what you could do is find out this part, this fraction first right here, this fraction, then add 1 to that. And now it's important that you don't do any rounding earlier than your final answer. No rounding in any of the intermediate computations. It has to be in the end value. That's the only rounding. Everything else should be in its fraction form or whatever you can put it in. So try to put it in fraction form. And now one of the secret ways to do it with this great TI-84 plus CE calculator is you have this math button right here. You click the math button, boom, you have the fraction, just click enter, and what, 0.051 fractions? There you go, 1 over 20, the most simplified form you could get of the fraction. So that's a secret way if you didn't want to put the work of trying to find out the fraction of something insanely hard to figure out. So there we go, I solved it. Now it already comes out in a number that doesn't need to be put into fraction because there's no repeated, it terminates very quickly and is not a very long decimal, so I just put that on. So now this area right here has been put together, and now I'm just going to put an arrow to show the steps. 600 over 500 is 6 over 5, 1.2 for this part, 1.2, this is 1.2 here, so 1.2 equals 1.0125. Now that is still in parentheses with the 4t. Now you might be wondering what to do. Obviously, if you don't know logs, back before when you learn this, right before learning logs, the secret to it is just guess and check. That is not what we're going to do. We're going to find the exact answer out. The way to do this is through logs. The simple way of doing it is we learn this one technique where we take out the exponent like we have done with other things, where you divide to take out this 500, you divide the 500 to take it out. In the same way, we use logs to take out this exponent thing right here. What you'd use is your log 1.0125. That log cancels out with this exponent, boom, that's gone. However, this is an equation. This is not your, this is an equation. So that means it goes both sides. It has to go both ways. So now you have a log 1.01125 as your base, and you add in that 1.2 as your argument part. So that's on one side. And then this, because this cancels out, your 4t is what's left over here. So now what you get is you get log base 1.0125 and then 1.2, your argument, equals 4t. Right there. That's what you get. This part right here is this is your base of the log, this is your argument, and that. So now you're thinking, okay, how do we do this? Now obviously you need a graphing calculator for this, but what you can do is another thing that's in one of my lessons, the base change formula. The base change formula requires that you change the base into something that's common. Our common base is our log 10, or you can do your natural log. You can choose whatever. I'm just going to do log 10. I'm going to do that because I think I just like logs better than using a natural log. But it really doesn't matter. You can use whatever. So now how this looks is you have log. You're not putting a base because pretty much your base is 10. So I don't need to put this base 10. This is just as an argument. Log 1.2 divided by log 1.0125. This right here is what equals exactly this. This whole part right here equals exactly what's going on here. You change the base to log 10, and you have your argument 1.2 divided by the argument 1.0125. You get exactly this answer right over here. Then you do need to divide by the 4, so I would just recommend doing that over here. But the 4 equals t. Now put in your calculator exactly what's going on here. I'll show you the final thing that goes in here. You have your log button if you don't know what it is, log right here. You can use that log, natural log 10, or your natural log here, or your log 10. So log 1.2 divided by your log 1.0125 here. And this is part 1 of the thing, enter that. Then you know that you have the divided 4 there. Divide your answer 4. Boom, final answer right there. Simple answer. Now obviously the question should tell you where to round. This doesn't, so I'm gonna do 10, 100, 1,000, thousands place. You can do whatever you want. So final answer t, putting it over here. I always put t and a little awkward. I don't do your normal classic, just normal, like straightforward, normal classic t, printable t, because it will start to look like a plus sign, and that annoys me. So that's why my t's are kind of awkward looking. So don't blame me for that. But 3 point from this right here, kind of hard to see. 3 point. Put this in the. No, it doesn't count. 3.669. 3.669. And then remember, you have to put your what is it? Your units. Units here, time. So the time is years. Final answer for this first question. Now I'm going to do 2, 3 more, and then we're going to finish. So this is the full thing. Just want to see this. Right here is all the work for this one question. You should pause it in the beginning if you want to do it yourself, and then check your answer to see if it's correct, and then all the steps if you want to do this question. And I'll be doing 2, 3 more for you guys. Actually, I think I'll just, no, I don't think I'll do 2, 3 more. I'll show you how to do the compounding Uh, I'll do like, yeah, I'll just do a few more. So I'll just show you. I'll go a little quicker with the next one because pretty much if you know how this is done, all we're going to do instead of using our full formula here, we're going to just replace this whole thing with E. So we're going to have A PERT. So the P, E, exponent RT. So that's our next question. So let's get that done and then I'll come back. Alright guys, I'm back. We're doing question 3 now. So I'm just going to move that to the side. Just a little break right there. But here we go. This is the question. Put the light closer. Connor deposits $400 into an account earning 5% annual interest. So your $400 principal, 5% annual interest rate, principal, compounded continuously. This secret word right here gives it away that you're using E. Then how long will it take for her money to reach this? Oh, final amount. We put that as there, 8. Pretty much have the whole thing set. 700 equals 700 equals principal amount 400. Actually, I don't need to do that. 400 E. Then exponent comes in the rate. Needs to be in decimal form, 0.05. And we're doing how long. That's your time. Do the awkward T there. So that's what we got. 700. Final amount equals 400 E. E because it's compounding continuously, 0.05 your rate, and T your time. So we need to do the same thing. We have to use logs for this. I'm going to go through it a little quickly. Same thing, divide the 400 and put it into the 700 here. And here we got 7 over 4 pretty much equals E 0.05 T. So 7.4, put in the calculator to see if you can get a standard thing, and yep, you do. 7 over 4 gets 1.75, so I can just replace this right here, 1.75. Now what you need to do, you have to do the same thing, logs, to take out the exponent, make it more standard. We are going to use logs to remove the exponent. So because we don't need to use log E, we can actually use something else which represents log E, our natural log, ln, which is in the calculator. So this actually gets a lot easier to solve because it's already in calculator. ln cancels out here, ln adds on, you have your argument of 1.75. We're going to put that up, ln 1.75 equals 0.05 T. Okay, now you can see here we have ln 1.75, our argument equals 0.05 T. I'm already going to go straight in and put that 0.05 over here. We want to isolate our variable so that it becomes easier to solve, and then we can finally find out the final answer. And obviously if you already want to include years is the way to go. Years right there. So now I'm going to put this in the calculator and I'll show you here. So this natural log button right over here, natural log 1.75, then you put that over 0.05, and that pretty much gets your answer. So right here is what you need to have in your calculator. Enter, easy solve. Now I'm going to round this to, we can do the same amount of places. We can do 1,000. So from what we have right here, $11.192. That's your final answer right here. I'm just gonna circle this. Oh, can't forget the years. Have to add your units in there. And that's your answer for another one. We used E in this. Now I'm going to show you 2 more quickly. We're going to do one Half-Life 1 and one about the value. So let's get that done. Alright, next question. this is our next one right here, the SpongeBob one we're doing. Okay, so SpongeBob SquarePants, we're gonna take that out. We're not doing any square pants. We're doing round pants. SpongeBob Round Pants bought his car in 2008 for $15,898. If the value of the car decreases by 15% each year, after how many years will the car be worth $10,000? Round your answer to the nearest tenth. So basically, we're going to use the formula that is pretty much the compounded interest formula, but we don't have a compounded interest. We don't need the n. That n becomes 1. So if you do remember the compound interest, you can just remember it that way, or you remember the formula where we had y equals a the principal, over 1. And now what is it, decreasing or increasing? Decreasing, so you need to put that minus sign, 1r over time. So we're trying to find the time again. We need to use our log, so we're going to go a little quick with this. Bought the car for this much. That's your initial amount. So now what we're going to do is 15898. Then we know obviously 1 minus how much rate? 15% right here. Put it in your decimal form. Sorry. 5 time. That's what we're trying to find out. Just leave that variable how it is. Now we know our final thing. How much? When will it be worth 10,000? 2, 3. There we go. Final answer. Y corresponds here. A corresponds here. This whole section corresponds here, and your T is what we're trying to find here. T, remember, we'll do years, and now it actually tells you finally what we're going to be rounding to. Nearest tenth of a year. So that's what we need. We don't want to round it to just like whole years. We're going to round it to tenth of a year. So, yeah. Okay. So, now same thing, divide here, then we divide this over here. 1, 2, 3, 4 over 1, 5, 8, 9, 8 equals, I'm going to simplify all of this. Even this section right here can be simplified. I'm going to isolate our answer, and we're going to have to use a log thing too, so let me just quickly put in the calculator here. So 1, we're going to get this one. Now look at how it goes like that. So we're going to click our math here, fraction, enter, enter. That's our fraction. Point of fraction form is it's much easier than, we don't want any intermediate computation roundings. And then, so basically, then we're also trying to find 1 minus 0.15. That's that number. So now a simple thing to take out the exponent, I've already done this before, use log 0.85 as your base, cancel that out, you got t left. Same thing, you have to do it on both sides, so 0.85, argument becomes this right here, so now what it looks like is log 0.85 with 500 over 7949, 5,000 I mean, equals t, because we canceled out the rest over there. Now pretty much you just solve this, and the way to do that would be,
so from here you put log 5
standard, don't write that
thousand
down.
over 7949. The mistake I made is I put 500. That is why the answer comes out incorrect. But the rest of the steps are correct, so follow that. So everything here is correct, but that 500 that you can see at the top of the log needs to be 5,000. So the final answer does not become the 17 that I got. The actual answer should be 2.853 years. Sorry for that mistake there. And I just realized that I had made a mistake. So when you guys make mistakes, always good to check it again. So hopefully that
here
solved the problem.
Is the answer to this question. So now, obviously, what do we need to round to the 10th? So 17 is basically your answer. And because this is 10th, we're going to put that 17.0 there. So right here. Final answer. Okay, now I'm just going to show you one more question and then we'll get it over with. One question of half-life. One more problem. So iodine 131 is used to destroy thyroid tissue in a treatment of an overactive thyroid. The half-life of iodine 131 is 8 days. If a hospital receives a shipment of 200 grams of iodine 131, how much I-131 would remain after 1 month, which is 30 days. So, iodine 131 is used to destroy thyroid tissue in a treatment. Half-life of iodine 131 is 8 days. So what we need to do first is find the rate. So the rate is using our formula for continuous compounding. So basically what you would have to do is 0.5 is our product, because 0.5 and 1 would be what we started with 1, and our half-life is 0.5. So that's what we're trying to find. And E we're using because it's continuous compounding for half-life, and we know that time is 8 days, but we're trying to find that rate because it's PERT, and we know 8 days is that. So if we can find this rate, do not round this rate number right here, we can answer the rest of this question. So basically what we do is simple. 0.5 divided by 1 would be 0.5 still. So now we just have, and then E here, to take that out, we do natural log. Natural log takes that out, so now we have natural log. We need to do natural log on this side as well. Natural log 0.5 equals R, or 8R, you could say, divide the 8, divide the 8. Now we have line 0.5 over 8 equals R right here. This right here will tell us the rate. Now we just put that into our calculator here. So now natural log you have on the calculator, and you just put that in. So this is the number you should get right here. Do not round this. Keep this in your calculator so you can do the rest of the question. Alright, so now you know that. Just keep that in your calculator. If you want, you could just write it out here, the whole thing, but I'm not going to. I'm just going to put 8, 6, and dot to show that the rest. Now we're going to put the whole question. So the half-life is 8. If the hospital receives a shipment of 200, so 200 grams is your initial amount. How much would be remain is you're trying to find that out after 1 month. So our time period is 1 month. So E goes here, 1 month. We have 30 days, and we have our rate. I just put an arrow there showing that. Now what you're going to put into the calculator is, so first you want to focus on this E part, 30 R here. So focus on this, put that in your calculator. So we already have this number right here. So based on the equation we have right here, we just go second E. That's what you have right here. So what you put in is 30 times, go up, just enter that, and it comes in right here. Boom. That's your answer for this right here. Now we just need to multiply that by 200. So multiply 200. Boom. That's your answer. Just put it all into your calculator and easy solve. And even if you're doing the SAT, you'll be given a calculator probably for these kind of questions. So now you've already got your A equals 14.865 right here, rounding to thousandths. And obviously you have to put your units as grams because they showed grams right here, so that's what's going to be left over. Grams remaining. This number right here is your answer. Now I want to say that for one of the questions I have made a mistake, and because I made that mistake I made one error and I forgot putting a 0 into it, so that's what made a mistake there, but I will tell you the complete answer and come back to you. So hopefully you enjoy. Please like and subscribe for more videos. Thank you.